Graphing linear patterns. Learning goal. I can switch between representing linear patterns with numbers and with graphs. I can explain what each kind of representation shows and how it shows that. We're going to start off by creating 3 patterns that fit each description for pattern A, B, and C and D above. We're told to make sure that at least 2 of those patterns include rational numbers that are not integers. Remember that a rational number is any number that can be created by dividing one integer into another. So as an example, we could say a pattern goes 5, 10, 15, 20. So that's pattern A. It meets the requirement of starting at 5. Or we could say 5, 5.25, 5.5, 5.75, and 6. Or we could say 5, 6.5, 8, 9.5, and so on. Pattern B could be 3, 6, 9, 12, 15. So that's a pattern that increases by 3. Or 7.2, 10.2, 13.2, and so on. Or negative 30.5, minus 27.5, minus 24.5, and so on. Pattern C could be 1, 2, 3, 4, 5, and it keeps going until it hits 10. Or you could start at 5.5 and go up by half intervals, so 5.5, 6, 6.5, 7, and so on. Or you could start at 23.5 and go down by 1.5 each time. 23.5, 22, 20.5, 19, and so on. And finally, pattern D needs to be a pattern that decreases by 4, so we could go 20, 16, 12, 8, and so on. Or 12.5, 8.5, 4.5, and 0.5. Or one more, 16.1, 12.1, and 8.1, and so on. Now we're asked to create a table of values to describe the first 5 terms of each pattern in question 1. Then graph the patterns. So let's look at our first table of values here. Pattern A, over 1 up 5, over 2 up 10, over 3 up 15, and so on for 25, 25. Now look at the second set of data. This one is 1, 5 again, so it's the same starting point there. 2 to 5 1/4, and then over 2 up 5 1/4 is just a little bit higher. Then over 3 up 5 1/2 is a little bit higher than that. This is going to be very hard with this scale on here. 4 5 3/4, and 5 goes all the way up to 6. I don't think my graph is very accurate there. And the third set of data again starts at 1, 5, then goes to 2 to 6.5, a little bit higher than that one. 3 up to 8, higher again. 4 up to 9.5, just about getting to 10. And 5 is at 11. Okay, looking at the first set of data for pattern B, we've got over 1 and up 3, over 2 and up 6, over 3 and up to 9, over 4 and up 12, and over 5 and up to 15. Now on to the second set of data. We're over 1 and up 7.2, over 2 and up 10.5, over 3 and up 13.2, over 4 and up 16.2, over 5 and up to 19.2. Now the third set of data. This time it's over 1 and down to negative 30.5, then over 2 and at negative 27.5, over 3 and down to negative 24.5, over 4 and down to negative 21.5, and over 5 to negative 18.5. So this is a little more accurate representation of the graph. And we've gone through and done the same process for patterns C and D as well. Now we're asked to choose one pattern from each group of patterns and use our graph to figure out the 12th term in that pattern. So let's go back to the A. Now the easiest way to figure out the 12th value, rather than doing every step in between, because we know this is a straight line, I'm going to go ahead and draw a straight line through all of the points. And we can see that by doing that now, when we're at 12, crossover, we're at 60. So the graph then helps us figure out the value for the term 12, and we find that it's 60. In pattern B, using a similar approach, if we connect a straight line between all of the data points, when we get to 12, we can see that it looks like we're at 5. In pattern C, connecting all the dots, going all the way up to 12, this time it looks like we're at about 12 on the vertical axis. Pattern D, and our graph might not have been perfect for doing this, it looks like it's at about minus 20. Maybe even minus 22. Now we're asked to tell one way the 3 sets of data points each graph of question 2 are alike. So let's go back and look at the graphs. So looking at the pattern A graph, one thing I notice is that they all went through the same point. In pattern B, one thing I notice is all of the lines are parallel. In pattern C, all of the lines have a different slope, and as a result, they're all going to meet at some point out there in the future. And it looks like they all meet at term value 10. And pattern D is similar in that it looks like all of the lines are parallel. Lesson summary. A graph of a pattern is made up of points based on a table of values that describes the x and y coordinates of those points. For example, this graph shows the points in this table of values. You can see we've got 1, 7.5, and that shows up here on the graph. Similarly, 2 at 14.5 is here on the graph. So you can think of the x and y here as being the n value and the term value. When graphing a pattern, the x-coordinate represents the term position and the y-coordinate represents the term value. For example, you could graph the pattern 5.5, 11.5, 17.5, and so on, using the points 1, 5.5, 2, 11.5, 3, 17.5, and so on. Here's the graph that represents that information. You can see we've got 1, 5.5, and that's what's there. 2 at 11.5, and that's that point there. And so on. Since the term position is always a positive whole number, there is no need to include quadrant 2 or 3 of the Cartesian plane in the graph. This graph shows that one pattern starts at 4 and the other pattern starts at 7. It also shows that one pattern increases by 3 and the other pattern increases by only 2. You can read out the numbers in the patterns by starting at x equals 1 and listing the y-coordinates as you move to the right. The patterns shown on this graph are 4, 7, 10, 13, and so on, and 7, 9, 11, 13, and so on. Where you see the two graphs have the same value, that indicates that the two lines would actually be meeting if you connected all the points. Key terms. Table of values is a table for displaying two sets of numerical data so that relationships between the numbers can be seen. Your turn. The questions you need to answer are in Google Classroom. They're a little too big to fit on screen in this video.